Okay, Assalamualaikum and hello. So we continue our last part of chapter 2b transformer, which is auto transformer and three-phase transformer. Okay, so this topic is much more towards uh, theory rather than uh, the calculation. Okay, so what is an auto transformer? Okay, it is a transformer who has primary and secondary winding while as a single winding. So normal transformer are usually you have a first winding and then you have a second winding. Okay, primary and secondary. But for auto transformer, it's only one winding. Okay, you have one this and then you have a tab here. Okay, tab and something like this. Okay, you have only one winding. Okay, that is auto transformer. Okay, so you can see here, this is the picture of the auto transformer. Okay, so same operation as two winding transformer. Okay, same thing. Physical connection from primary to secondary means that you see here the primary and secondary winding are the same. Okay, if you have a normal transformer, you have a separate winding, but for auto transformer it is the same winding. Sliding connection allow for variable voltage. So the advantage of the auto transformer is that you can move this. Okay, if you have okay if you have this one, okay, actually you can move up and down to adjust the number of winding. So basically you have V1 here, V2. Okay, V1 is usually constant, but V2 can change. Okay, the output can change. You just adjust the sliding connection. Okay, this one can slide. Okay, for this one you cannot do. Okay, usually we have type changer. Type changer you can change the voltage, but usually it's quite difficult to change the voltage too much. But auto transformer you can adjust it easily. Okay, okay, and higher kVA deliver than two winding connection. This one just ignore. Okay, okay, what is the advantage of auto transformer? You need to know this. The tab between primary and secondary side, which may be adjustable to provide step up and down capability. So this one I told you before. The advantage is you can change the voltage easily. Okay, able to transfer a large apparent power than two winding. So this one you have a limitation of apparent power, but this one you don't have the limitation of apparent power because you have a same connection. Okay, and also you have smaller and lighter than the equivalent to winding transformer. You can see here you have first winding and second winding, but this one you only have one winding, so it is much more smaller and lighter. But the problem is the limitation of auto transformer is that you don't have any electrical isolation between primary and secondary. So you can see here, this one is directly connected, this one is not. So this one is for safety, isolated. Okay, primary and secondary has no electrical connection. Okay, it is connected to magnetic. Okay, this is the magnetic circuit. Okay, so this is the normal transformer, but for auto transformer you don't have that, so no isolation, so that one is disadvantage. Okay, okay, now we move on to the calculation. Okay, it's only a little bit calculation, no need to worry. Okay, so if you call back, normal transformer is V1 divided by V2 equals to N1 divided by N2 equals to I2 divided by I1. Okay, so this is a standard transformer. Okay, so how about the step? Okay, auto transformer. So you have two formula for auto transformer. You have step down and step up. Okay, so step down you need to know the formula. So the formula is usually V1 divided by V2, okay, this is basically A, okay, turn ratio, equals to N1 plus N2 divided by N2. Okay, so make sure you know that number of primary winding N1 and N2 divided by N2. Okay, this is the difference, the number of winding. And if you simplify this, it's just become 1 plus N1 plus divided by N2. Okay, this is for step down. If you, how about the current? Okay, I1 divided by I2. Okay, of course, it is easier if you just equals to I2 divided by I1. Okay, so something like this. So it's easy. Okay, but for step down, step up transformer, it is different little bit. So of course, V1 divided by V2 equals to A equals to I2 divided by I1. Now instead of N1 is the change one, is N2, N1 plus N2. So make sure you memorize the formula. This is for step up. Okay, so step up, the bottom one needs to N1 plus N2, and for step down, the upper one needs to be N1 plus N2. Okay, so this is an example on the calculation of the transformer. So example 4.7, an auto transformer with 40% taps is supplied by 400 volt. So tap, okay, you can see here 40% tap means that, remember that I said that it is something like this, winding, and then this is the tap. Okay, okay, this tap is connected here. Okay, so what it means to have 40% tap, this is 40%. Okay, 40% tap. Okay, supply is 400 volt. Okay, V1 is 400 volt. Okay, 60 kilohertz. Okay, 60 hertz, sorry. So this is a step down. Okay, step down, make sure you be careful. This one is step down. Step up is something like this. Okay, this one I'm not sure too much. Okay, maybe something like this. Okay, okay, this is step up. Okay, be careful. Is flip. Okay, this one is winding. Okay, so step up, step down transformer. Okay, so 5 kVA load, so S is equals to 5000 VA. Okay, operated at unity power factor, PF is equals to 1. Okay, so find the secondary voltage. So remember the formula V1 divided by V2, because this is step up, N1 plus N2 divided by N2. Okay, so you want to find the V2. So you manipulate the formula, it will become okay, because you want to find V2, right? So N2 divided by N1 plus N2 multiplied by V1 equals to V2. So V2 is equals to, V1 is 400, N2 is, remember this is 40%, this is 100%. Okay, that it means by 40% tap. So you can see here, V1 is 400 multiplied by N2 is 40%. Okay, divide by 100%. Okay, so you get 160%, maybe. Yeah, 160 volt. Okay, so you get the first voltage, the secondary voltage. So how to obtain the current? Use the formula, of course. So primary current, so calculate the secondary current first. So I2 is equals to S divided by V2. So S is 5000 kVA, 5000 VA. divided by V2 is 160, you get 5000 divided by 160, you get 31.25 ampere. Okay, so I1 is, okay, so you just refer back to the formula. V1 divided by V2 equals to I2 divided by I1. So from this you get I1 equals to I2 V, this one is V, V2 divided by V1, I1 is equals to 31.25, 160 400. So you get, okay, so 160, okay, so you get 12.5 ampere. So this is how you solve the auto transformer. Okay, so let me check 160. Okay, yes, the answer is here. Okay, now we move on to the next part, which is three-phase transformer. Okay, auto transformer, usually the question is simple, no need to do a practical. Okay, practical transformer. So for your level, okay, for your course, only the ideal one. Okay, now we move on to the three-phase transformer. So the first thing I teach you on the transformer is it is only a single phase transformer, but usually we use the three-phase transformer. So no need to worry, because three-phase transformer is actually complicated, and usually in your syllabus we don't include it. Okay, so you just need to know the theory. Okay, three-phase transformer. Three-phase transformer can be built by interconnecting three of the single-phase transformer, or use iron core with 3 limb. Okay, what this means is, okay, so you have the first one. Okay, you have two types. Okay, the first one is the single phase transformer. You take three single phase transformer, TX and here TX. Okay, you have three phase transformer, you connect it together. Okay, A, B, C. Okay, so you have three. Okay, this is one way to do it, or another way, you just use a large three-phase transformer. Okay, usually this transformer has 3 limb. Okay, what means by 3 limb? You have something like this. Okay, you have the winding A, winding B, winding C. Okay, and the secondary part will be at the top, usually at the top. Okay, winding again. So that is how you use a iron core with 3 limb. So this is two types of transformer available. So the usually connection of three-phase transformer are Y, Y, Y delta, 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 and delta Y. So what is this mean by, okay, if you remember transformer, okay, you have two circuit, primary winding and secondary winding. So for transformer, you have, okay, for example, YY. So why you do something like this? Okay, this one is A, this one is B, and then this you do a winding here, this one is C. Okay, recall back your three-phase system. Instead of using impedance, you use winding, and if it is YY, means that you have winding, primary winding and secondary winding connected as Y connection. Okay, star connection. Okay, so this is A, B, C. So this is A2, B2, C2. This is primary winding. Okay, so this is how you draw the three-phase transformer. It's basically inside here. Okay, make sure you know how to draw this. Okay, you can see here different connection has different, okay, different application. Okay, so I give you another example, y delta. So if y delta is something like this, okay, y, okay, so b1 a1 b1 and c1, this is y connection, and then you have a delta connection. Okay, okay, something like this. Okay, okay, make sure you know how to draw this. Okay, a2 b2 c2. Okay, so this one is the primary, this one is primary, this one is a secondary winding. Okay, so that is how you know how to draw the y delta, delta y, delta delta. Okay, connection of three-phase transformer. Okay, so you also need to know what is the application for y is rarely used. Y connection is rarely used because it has unbalanced and three-phase harmonic problem. Okay, so in step down transformer we usually use, okay, y delta connection. Okay, frequency step up, use step down. Okay, frequently used in the step down transformer. Delta delta usually used in the okay, medium voltage. Okay, the advantage of the delta delta, you can open one of the phase. Okay, other transformer you cannot do that. Okay, you need to have load for all all part. But if you use delta delta, you can open one phase. Okay, if you don't have one load, okay, in one transformer, you can one phase you can operate it. And another one is delta y, this one usually in the step up. Okay, so basically make sure you know the application. Okay, and one more thing, most cases the neutral point is grounded. Okay, usually this one is for delta star lah. So this is y, okay, or star connection. Usually this one is grounded. Okay, so make sure you know. Usually for step up transformer, this one you delta and then y connection, and then you step up. Okay, step up, this one transmission. Okay, and then you have a y delta. Okay, so y delta connection. Okay, this one you begin to step down. Okay, step down, and then you use delta delta. Okay, step down. Okay, step down. Okay, make sure you know the application. Okay, how to draw it. Okay, analysis of y delta transformer. You can see here y delta transformer usually in the step down transformer. Okay, so you can see here this is the winding. Okay, so remember that I say you need to have a transformer core. Okay, let me draw this, easier to understand maybe. Okay, you have a transformer iron core, something like this. You have three legs. Okay, something like this. Okay, this one usually is symmetry. I cannot draw it symmetry. So you have the first winding. Okay, usually the first winding you have something like this. Okay, and this one the second wind, the primary winding also, but this one is the B phase. Okay, and this one is the C phase. Okay, and for Y connection, okay, Y connection, you just connect this together. Okay, so why? Because this one. Okay, you have winding here, winding here, winding here, so you just connect everything together. Okay, and then for the secondary part, okay, you have a winding here, winding here, and winding here. So if you use delta here, okay, so A, B, C, this one is A, this one is B, this one is C. So A and B is connected together, B and C, okay, this one is a little bit tricky. Okay, so you have this one is connected to this one, connected to this one, and then this one connected to this one, okay, and this one connected to this one, and you have three phase. Okay, so it's something like this. Okay, so you have A, B, C. Okay, make sure you know how to draw this. This is just a theory. Each leg has the primary and secondary winding. Okay, each leg, this one is the leg A, leg B, leg C, has primary and secondary winding. The voltage and current are in phase in the winding located at the same leg. So basically, okay, the phases for this one and this one same. Okay, the voltage is not the same. The voltage and current, remember, V1 divided by V2 equals to I2 divided by I1. So basically, voltage change depending on the winding, but the phase at the same leg remain the same. Okay, so basically, if this phase is V1 angle 20 degree, so at this phase is V2, okay, it changed, but the phase is also 20 degree. Okay, so this is the ground. Okay, this is what I say. You need to, if you have Y connection, you need to ground it for transformer. Okay, and this is Y delta also. Okay, Y delta. So VAB, VBC, VCA. Okay, you have to recall back your chapter 1B. It's almost the same. Okay, except that you need to transfer this phase into here. The voltage changes. Okay. Okay, this one is okay. No need to worry for this. Okay, I already explained before. Okay, this one also the same. Okay, this is the calculation. For your case, I think no need to worry about the calculation for three phase. This one is quite advanced, and I think your syllabus doesn't cover this. So this is just an information you need to look at, but no need to understand too much. Okay. Okay. I think this one also I already explained before in the transformer theory. Okay, and the beginning of the class. Okay, almost the same. Okay, you can see here three-phase transformer construction of the iron core. Of course, it made with the thin laminate. Okay, silicon steel. So basically, instead of using one big core, you just use a slab of core. Okay, something like this. And in between, you have insulation. Okay, why you do this? Because to avoid, okay, eddy current actually, to avoid eddy current. Okay, okay, this one I explained. Okay, sheet are overlaid to each other to avoid reduce air gap. Okay, and the core is pressed together by insulated yoke. Okay, like I told you here, you put an insulator between this. Okay, one of the advantage is to avoid eddy current. Okay, this is another construction of three-phase transformer. Okay, winding are usually made of copper, aluminium conductor, insulated paper. Okay, something like this. Okay, and the winding are manufactured of several layers. Okay, already explained. Okay, you have a winding here. It's not only one layer, you have multiple layer. So what it means that, okay, let me show you. Okay, this is you assume this is the cross section of the transformer. Okay, and okay, You do a winding here, winding. Okay, you do a looping here, but sometimes the leg doesn't long enough, so it means you have to put a second layer. Okay, that's it. If one layer not enough, you put a second layer. Okay, and winding are dried in vacuum and to eliminate moisture. Okay, you don't want moisture inside the transformer. Okay, this is the construction as I showed before. Okay, so you have three legs here. Okay, square and square. Okay, the primary winding usually at the inner side of the leg. Okay, something like this, and then you put the secondary winding at the outer side. Okay, so the second layer, something like that, second or third depending on that. Okay, so a phase winding is placed in each leg. A high voltage and low voltage winding are placed on top of each other. Okay, so usually your alternate it. Okay, maybe this is secondary winding. Okay, and then you have the primary winding back. Okay, and then you have the secondary. So depending on the design. Okay, larger transformer use layer construction shown below the previous slide. Okay, and this one dry treated placed in the steel tank. Okay, sometimes the construction of transformer is put in the dry tank. Okay, means that you don't have any moisture here. Okay, and it is under vacuum or oil. Okay, either you make it vacuum or you put it in oil. Okay, so ending of the winding. Okay, the end, the connection, the bus bar, the bus. Okay, you put here. Okay, connect at the bushing. Okay, the oil is circulated by pump and forced through radiator. So this one usually just to cool down. Okay, usually the transformer become hot, so the oil will be pumped and circulate the radiator outside here. Okay, the heat will exchange with the air. Okay, and okay, this one already explained. Cooling radiator here. Okay, forced ventilation. Okay, make sure the transformer is cool. Okay, usually they are cooling fan or they just air. Okay, just open it. Okay, no fan. Okay, large bushing connected to the winding of electrical system. Okay, and oil circulate. Okay, this one already repeated. Oil temperature, okay, and pressure are monitored to predict transformer performance. Okay, usually they have a thermometer and pressure monitor system. Okay, to ensure that the transformer is at the optimum state. Okay, this one is dry transformer, means that you don't use oil. Okay, it's just open something like this. Okay, vacuum. Okay, and this one usually for medium and low voltage. Okay, so the winding you put it in the vacuum, okay, container. Okay, and the winding is insulated in epoxy resin. Okay, this one is an insulator, some sort of. Okay, you can try to Google it. It is epoxy. I'm not sure how to explain it. The slide show three phase. Okay, this one is the three phase dry transformer. Okay, that's it. That is, you need to know extra information about transformer, three phase transformer, as well as auto transformer. Okay, so that's it for this chapter. Okay, next we will learn the chapter 3. Okay, don't forget to slide in your attendance. I will place the attendance in the e-learning. Make sure you'll slide in your attendance. That's it. Okay, thank you.